Hi, I'm Lisa and this is Threshold in China. Today we are going to share some exciting tech innovations and announcements that happened in China last week. Robots are coming. Tesla recently introduced its cutting-edge humanoid robot, Optimus, and at the same time Xiaomi introduced Cyber One. The two companies reflect the larger picture of the fierce competition in robotics between China and the United States. Let's take a look at this new report that tells us where each country is at. The United States has been at the forefront of the robotic research. It has the largest number of first authors and institutions publishing papers in top journals, solidifying its dominance. Meanwhile, China has emerged as a rapidly developing force, securing the second position, overtaking Europe, Canada, and Japan. Data shows a changing of the guards, with China surpassing the US in 2022 in the number of first authors and institutions publishing in top journals. Hence, China is narrowing the research gap. Prominent Chinese universities such as Shanghai Jiao Tong University, Tsinghua University, Huazhong University of Science and Technology, and Harbin Institute of Technology are making significant contributions. Keyword analysis shows that there are differences between China's and US research directions. From 2022 to mid-2023, China focused on deep learning, reinforcement learning, digital twins, cloud manufacturing, soft grippers, and technologies with variable stiffness. In contrast, the US zeroes in on safety collision avoidance, robot perception system, multi-robot system, and path planning. The focus area differ according to strategic priorities. China aims to transform manufacturing through innovative technologies. This will contribute to China's lead in industrial robot development. According to the IFR, over half of new installations last year occurred in China. Therefore, its main robotic research concentrates on areas facilitating advanced automation solutions. Deep learning and reinforcement learning are crucial for developing more autonomous robotic systems capable of complex tasks. Another focus has been on digital twins, which are virtual representations that allows the digital modeling of physical systems so they can perform model, test, and optimize processes remotely. This aligns with China's goal of transforming manufacturing through technologies like cloud-based factories. Soft grippers and variable stiffness mechanisms aim to make robots safer and able to interact with unpredictable environments, like in medical or logistic applications. Meanwhile, the US centers on safety technologies. Algorithm for navigation, perception, and collision avoidance are priorities, ensuring robust coordination and autonomous machine operating around human. The different focuses each country have on research reflect their economic goals and societal needs. We can expect the China-US tech war will intensify as the robotic field evolves. China has announced its plans for deep space exploration over the next 15 years. According to Wu Weizhen, chief designer of China's lunar exploration program, the country aims to carry out 10 major engineering missions across 3 areas: lunar exploration, planetary exploration, and launch vehicle technology. We have talked about the 4 lunar exploration missions in previous episodes, so if you're interested, the links are down below. Let's dive into the planetary exploration. China plans to launch Tianwen-2 in 2025 to sample an asteroid and fly by a main belt comet, bringing pristine out-of-Earth material back to Earth. China will also carry out its first ever near-Earth asteroid defense mission to address the small but potentially catastrophic probability of an asteroid hitting the Earth. China will perform a kinetic impact on an asteroid located millions of kilometers away, altering its trajectory and assessing the impact's effectiveness. Other planetary missions in the pipeline include Tianwen-3 to collect the first ever Martian samples and explorations of Jupiter and Uranus. The United States, through NASA, has a long history of successful missions to various planets, including Mars, Venus, and Jupiter. NASA's Mars rovers, such as Curiosity and Perseverance, have provided insights into the red planet's geology and potential habitability. The United States has also successfully landed multiple spacecrafts on Mars, including the InSight lander studying the planet's interior. China, on the other hand, has caught up in recent years. In 2020, China landed on Mars for the first time with their Tianwen-1 mission, which successfully placed a rover called Zhurong on the surface of Mars. The next major task of China focused on exploring the edge of the solar system. China plans to launch a new type of spacecraft that will reach the solar system's edge, 100 astronomical units away. This mission aims to contribute to humanity's understanding of the characteristics of the solar system's edge and its planet, and the exploration of aliens. To support these ambitious deep space endeavors, China aims to develop a super heavy lift Long March 9 rocket with 10-meter diameter cores and large liquid oxygen methane engines. This would increase China's launch capability to 150 tons in low Earth orbit. Regarding rocket technology, NASA has also been at the forefront for decades, with iconic rockets such as the Saturn V, which carried astronauts to the moon during the Apollo missions. In recent years, private companies like SpaceX have emerged as key players, developing innovative and reusable rocket systems like the Falcon 9 and Falcon Heavy. As a counterpart, China has been steadily advancing its rocket technology. The Long March series of rockets, developed by China's National Space Administration, has been the backbone of China's space program. These rockets have successfully launched various missions, including Lunar and Mars mission, and the Tianzhou cargo spacecraft for resupplying their space station. And they've just sent a new batch of astronauts to China's Tiangong space station on another Long March rocket. The nation's progress in deep space exploration over the past 2 decades has been remarkable. With that said, research benefits greatly from international collaboration, but the question is when this collaboration overcomes competition. Recently, US lawmakers urged to put restrictions on RISC-V, which is an open chip architecture standard increasingly embraced by China. RISC-V lets anyone customize computer processor design using its open instructions. Its flexibility has advantages. It reduces cost and allows custom chip for different needs. However, this openness has drawn the attention of US lawmakers who fear that it might pose a national security risk. They urge the Biden administration to regulate companies' involvement with RISC-V, potentially limiting its growth and use. Since RISC-V is an open standard specification, it cannot be prevented from being downloaded and used by anyone. So this raised the question of how the United States can regulate it, since it is almost impossible to do so. There is no monopolistic control on RISC-V standard, and this is the driving force behind this global adoption and a catalyst for the next phase of the chip technology revolution. However, US politicians contradict this trend by excluding themselves from the upcoming wave of transformation. So why are these politicians so scared? The underlying reason is that RISC-V disrupts the monopoly of the 86 and the ARM systems, creating a new ecosystem where the United States does not enjoy an absolute advantage. Currently, the Intel-developed 86 is the dominant chip design architecture for desktop and laptop computers, while the design architecture behind most smartphone chips in the world is controlled by ARM. RISC-V provides an open instruction set architecture to customize chip designs. Its flexibility is beyond established standards like 86 and ARM, and offers China a way to reduce foreign IP. Although RISC-V originated at UC Berkeley, China has become a major adopter. RISC-V's popularity in China is evident. According to statistics, among the 22 senior member organizations in the RISC-V International Foundation. 12 are from China, such as Alibaba Cloud, Huawei, ZTE, and Tencent Holdings, and 7 are from the United States. Among the 179 strategic member organizations, 49 are from China, 41 are from the United States, and 43 are from the European Union. Furthermore, the mentioned RISC-V servers, 10GB switches, and other products are manufactured by Chinese companies. If the RISC-V ecosystem flourishes, the global processor landscape will no longer be monopolized by the United States. So, the US politicians are really concerned with losing their dominant position in the processor industry. However, what they have proposed could be counterproductive in achieving their stated goals. It risks dividing an otherwise open community, severing the tie between Chinese and US researchers and engineers. As Chinese firms and institutions continue to advance RISC-V, China is posed to shape the next generation of processor technology on its own terms. And that is all for today's Threshold. We hope you like this news section on science and technology in China. And as usual, we welcome your feedback and thoughts.